好吧。我看到因为我们这样，没有这样长的线。
要拉过来呀。这样我们下个礼拜讲吧。
一样哦，因为这个片子很有想好玩的，其实
是，所以我们要换课室还是怎样？还是就是这样先
应该是不能，应该是没有课时换的，
没有课室，
好像是满的。
是哦。可是卖
没有卖，
没有卖啊，
因为真的没有，
要靠喊啊。
只能这样说的。那个的话，用这个
OK，
用这个 pod 的话，然后menu那边你要选那些卖上啊
OK，可以。行。
如果你不要这样子电的话呢，还有一个方案，
这样
就直接用它这边内置的 PC，就比如它就是跟 Windows 一模一样的。
OK，
你可以把你的那些所有的资料通过 USB 放在这边，
OK，
你就不用这样多线。
可以，因为我要 recording。
但是它是这样子的，如果你 restart 了过后，是不是它就会变成 default？
OK，不用紧啊，我用这个比较好，因为我要 recording。
可以。
所以暂时是先这样。
是这样子的。
OK，还是每个礼拜都这样？还是我问我 AA 可不可以换
？So cable 我们这边。
OK，买要买。
因为之前
哦，不能换课室吗？
我跟你讲，
我问一下，如果没有就是这样了啊。哦，then 我走了，这样我就把这个留在这边，还是电可以留在这边 ，HDMI 全部对。OK，可以。哎，你们的电话号码是这个吗？啊，这个
电话号码
还是哪一个 contact 表？
可以换5014啊。对，什么事情你就只能扣5014嘛。
对。OK，可以。好，Thank you 啊。
因为这边有事情只能扣吧。
明白，就是我再跑去另外一个房间扣。可以，Thank you 啊。Can I see? Can see? Maybe I'll just sit here. It's okay. I'll sit here. Otherwise, I don't have table. Can or not? Can hear or not? Can hear me or not from the back? From the back, can hear me? Okay. If you cannot hear, you ask me. Yeah. Okay. So any discussion? What's the answer? What's the answer? Okay. Another thing here, if you can help me, right? You can check the red light here, the red light there. If the red light is not on, then the recording is not on. Okay, if the recording is not on, then there will be no recording for the day. So if you can see that there's no red light there, make sure you will remind me. Okay, usually I'll start it before the class. And the other thing is, maybe you were concerned that my teaching style is quite different from your lecturer. I want discussion in the class. Maybe you think that it will take times. Okay, no worries. I will cut you if you take too much of my time. So I want you to discuss why, because your question could be the other student's question. So once I solve your question, maybe I solve all of your questions. Okay, so try to throw as much question as you can. Okay, so let's give some answer. Any brave soul to try? Do you have any answer? Sorry?
12 rabbits.
23 chickens and 12 rabbits. Okay, any other answer or not? Any other answer? Any other answer? Anyone agree or disagree? If you agree, maybe you can say agree. If you don't agree, maybe you say don't agree. No one agree and no one disagree. Huh? Agree. All of you agree. Wow. Good. Okay. Agree. So let me check my answer first. Are they the same? Okay. So can you share with us how you do it? Okay, try.
First one.
Okay, let me get out for a moment. X plus 5.
Or just use C plus R.
Okay, so we can address this later. So C plus R equals to 35. Good.
Then 2C plus 4R.
Okay, and then?
Then we solve the same.
So how to solve it?
C equals to 35 minus R. Then
And then
just insert that into, or substitute it into the second equation. So it's 2 into 35 minus R plus 4R.
okay, so you solve it.
Yeah.
So
then solving it, basically here you get R is, sorry, you get C is, oh no, sorry, you get R is 12. Then after getting R, you just
sub it back. Okay. Did everyone do the same or different? Similar? Same. Okay. Okay, good. So there's one thing. Okay, so there's one thing I want to suggest you is tell me what is C and R. Okay. Yes. Good. So a better way to put it is before even you start this calculation, you just say that let C be the number of chicken and R be the number of rabbit. Okay. Maybe you will think that very, very redundant. I thought I use C for chicken, R for rabbit. But imagine my question changed like this. Then maybe you'll get problem, right? You'll get into problem. So make sure you really define properly what are C, R, X, Y, or whatever variable you use. Okay, to be clear. Does it make sense? Because there's really no meaning here. Okay, but there's a meaning of number of chicken and number of rabbit. You cannot change this meaning. Okay, does that make sense? Okay, good, very good. Where did you learn these? Huh? Oh, so high school. Okay, very good, very good. Yeah, good. Yeah, cool. Yeah, I also learned this in high school. Yeah, system of linear equation. But we will do a little bit more than high school. Okay, so be prepared. All right, so let's continue. So every hour we will take about 10 minutes break. Okay, so maybe we will continue until 10:50 and then we'll take a break. Okay. Yep. All right, so let's define what's a linear equation is. Okay, so in mathematics, right, how to appreciate definitions? First, you need to look at the word first. Okay, so when you first look at this linear equation, right, what does it mean to you? Do you know what equation is? What is the equation? You have to give me an example of equation. So in maths, right, whenever you say you know something, okay, you should give me examples. So any examples of equation or not? X plus y equals 3 is an equation, okay? Because there's an equal sign here, equation. Okay, you must have an equal sign there. So what's a linear equation then? Okay, so I'll tell you what's a linear equation. Okay, so what's a linear equation? So this linear equation come in hand with variables, okay? So we allow a lot of variables, okay? Maybe we just put it x1, x2 up to xn, some n, maybe x100, x 1 million also can. I think a lot of you come from a XWE DMT background, right? Okay, so you process computer data. So there's a lot of data, I mean, variable you need to take care of. Even for accountants, right? I think there's a lot of accountants here also. Okay, you have a lot of data to take in each time. Actually, accountants students have a good track record in my class before. They are the top student in my class, actually. Okay, they know how to compute and then they read question well. Okay, so in the variables x1 up to xn is an equation. Okay, just now we address what's the definition of an equation here. Okay, it's an equation that can be written in a specific form. Okay, then the form of a1 x1 plus a2 x2 plus dot 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 plus an xn equals to b. Okay, so until this stage here, you should be worrying. Okay, what should you be worrying here? I told you what are the xi, but I didn't tell you what are the ai and b. Okay, so the next thing I need to do is I need to tell you what are these a1 up to an and b is. Okay, so what are these? So where b and the coefficient. So these are called the coefficients. A1, A2, up to n are actually real numbers. Okay, or complex number. You know what's a real numbers and complex number is? Okay, so yes, again, so meaning you need to give me a example. Okay, so what are the example of real numbers? For example, what? 1, okay, 2, 3, 4, okay, these are the integers. What else? -1, -2, -3, okay. These are the negative integers. Just now was natural numbers or positive integers. And then what else? Sure, 1.1, so decimal rational numbers, right? And then also the irrational numbers, maybe pi e. Okay, that you cannot write in a definite decimal expansion. Okay, yeah. Complex number, I. Okay, so there's an I here. So this I will satisfy I squared equals to -1. So you have maybe 1 plus I, something like that. Okay, this could be the choices that you can put in front of your variables. Okay, so maybe let's give some examples. Okay, example of a linear equation. So just now, what's your name? What's your name? Hebert. Hebert. Okay, thank you. Hebert. So just now you give an example, right? X plus y equals to 3. Okay, so this is an example of linear equation. Okay, so can I ask you, what is A1 here? What is A2 here? What is B here? 113, good, very good. Okay, 113, good. Because we can write this as 1 times x plus 1 times y equals to 3. Okay, yeah. Okay, very good. Any other examples you want to give? Maybe try one more examples. Okay.
5x plus 2y equal to 6.
Okay, good. So this is also an example. So what are the A1, A2, and B? 5 to 6. Okay. So note that this B here is a coefficient for 1. Okay, for 1. Coefficient for 1. Okay, good. Very good. So next definition. So if B equals 0, okay, so that constant term, okay, so this part here, we call it a constant term here because there's no variable attached. So if it is constant, so if this constant term is 0, then why my GoodNote is running? Then the linear system, then the linear equation is called homogeneous. If B is not equal to 0, then the linear system is inhomogeneous. Okay. So whenever you see the homogeneous word appearing, you are referring to the constant term. Okay, constant. These two definitions will come very often later when we solve a system of linear equation. Okay. One thing I want you to notice here is what are the power of these variables? You know what's power mean? Yeah, so the power is 1 here. Power is 1 here. So at this stage, whenever we talk about linear, you can think of it as a variable with power 1. Okay, for this stage. Okay, later you will see more apparent why we call a power degree 1 variable as linear. Okay, later. Okay, but for now, you can take it as degree 1 variable is linear. Linear equation. Okay, so you will notice that here I write x1, x2, xn, but here we write xy. Okay, so this is convention. Okay, so we call it a notation here. Okay, so sometimes we will use the alphabet x, y, z. Okay, x, y, z, w to represent variables. Okay. In fact, you don't want to use this also. For Chinese, right? Maybe you can use this Chinese character word. Also can. You can. Actually, this happens in your ancient China textbook. Yeah. I mean, surely you don't want to put so many, how to say, we call it 笔画. So too many lines. Okay, too many lines to use, right? X, Y, Z is easy to write. But this is what they did in the ancient China textbook. Yeah, Max textbook. Okay, so it's okay. Any alphabet is fine. Okay, as long as you define it properly. So what do I mean by define it properly? So maybe you should put it like this. Tell me what this word is for. Okay, we all have agreement on number of chicken, number of rabbit. So variable is just some how to say shorthand notation to write this number. Okay, does it make sense? Okay, yeah. So maybe if you go back to Africa one day, you can teach them using your Africa language. Yeah. So language is just a tool actually. Yeah. But knowledge is really important here. Okay. Okay. What time is it? 2 more minutes. So I think in your pre-read notes, right? there are 4 examples here. So 1, y equals to x. 2, x squared equals to 2 times square root 6 minus x1 plus x3. And then 4, 4x1 minus 5x2 equals to x1 times x2. And then 5, sorry, 3 and 4, x1 equals to square root x2 minus 3. So you are asked to decide, okay, whether they are linear equation or not, or they are homogeneous or not, or they are inhomogeneous or not. Okay, maybe can you spend maybe 1 minute to skim through this? Try to decide whether they are linear equation or not, or they are homogeneous or inhomogeneous. Okay, can you quickly screen through it? Yeah. Yeah. So what is homogeneous? So go back, previous page. Okay. So what is homogeneous again? So it's when the constant term b is equal to 0. Okay, the constant term b is equal to 0. If it's not 0, then it is inhomogeneous. Okay, so maybe if you look at these 2 examples here, so where are the constant term? Okay, they are 3 and 6. So they are not 0. So in particular, they are inhomogeneous. Okay, so both are inhomogeneous. Okay, so you need to look for the constant term b. Okay, so that's why suddenly there pops out a b here. Okay, because these ai are the coefficient for your variable. B is the constant. Okay, very good question. So can we quickly decide before we take a break? Okay, so for the first one, is it linear? Linear because the degree is 1. Okay. Is it homogeneous? Yes. So with b equals to what? You need to prove it right. With b equals to 0. Okay. Second case, is this linear? Yeah, linear because all the degree of a variable is 1. Is it homogeneous or not? No. Why? What's the b? Can you calculate the b? 2 square root 6. Very good. So you can write it as x2, x1, sorry, 2x1 plus x2 minus x3 equals to 2 square root 6. Maybe in this world, there's another kind of person, right? They will write it in different way. Okay, how would they write it? Maybe they will write negative 2x1 minus x2 plus x3 equals to minus 2 square root 6. Okay, it's still not equal to 0, right? Okay, still inhomogeneous. So it doesn't matter how you swap this equation. Still inhomogeneous. Okay, so still inhomogeneous with b equals to minus square root 6. Okay. So that's why this definition doesn't ask you whether this b has to be positive or negative or not. So what's not changed is the non-zero property. Okay, maybe positive, negative might change, but the non-zero property wouldn't change. Okay, look at 0. Play the same game with 0. What is negative 0? It is still 0. Okay, so that's why we make this kind of definition. Does it make sense? Okay, yeah, good. How about 3? Is it linear or not? Huh? No. So why is it not linear? Which term is not linear here? x1 times x2, because there are 2 variables multiplied together. In the definition, you only see 1 variable each term at most. Okay. Okay. Yeah. How about the last one? Linear or not linear? Not linear. Why? Because x2 has a power of half. Okay, not 1. Okay. Yeah. Okay, any question? Okay, so maybe sometime in class we cannot finish all the example inside your pre-fill notes. Okay, so you can do it and I will provide you after the class. In the class, maybe I'll provide other examples. So you will have a lot of example to see how the theory works. Okay, to help you to understand. Does it make sense? In the case, okay, in the case I forgot, you can request. Okay, I will do it for you. Okay. Okay, another thing is if you look at this Moodle before we taking a break, sorry, before we take a break, let me show you the Moodle now because just now we don't have computer. Okay, before we take a break, let me show you our Moodle. So if you are not in the Moodle yet, please let me know or email me with your ID. So there's a lot of reference book. Okay, this is the main textbook we'll be using. I give you the textbook PDF already. I even gave you the solution manual. So please try the solution, tutorial, and then you can check your answer. And if you don't understand, you can look for me. Okay, and I already assigned these tutorial questions for you to do. So help you to understand the subject. So please do it. And if you don't dare to ask me or talk to me, you can write here. Okay, you can put here, and then every time before the lecture, I will try to address your question. Okay, so far no one used this function yet. Maybe you are the first one. Okay, I'm waiting for you. Okay, so be sure ask me. Make sure you ask me if you don't understand. Okay, you need to spend your learning time here so that when you go out you can play. Understand or not? Okay, don't do your self-learning. You'll get headache because I know the subject, so you should ask me. Right or not? So spend your 3-hour lecture time properly in the class. After this 3 hour, maybe you can play, have your free time, and maybe have some time do some exercises. That's all. Okay. Okay. So don't do the opposite thing. Okay. So make sure you come and ask me. All right. Any question before I take a break? Okay. So let's take a break until 11:05. Okay. 11:05.哦，OK，OK，所以你可以发你的ID，发你的 ID
可以。
给我 email 也可以，给我 team 也可以。你是刚刚 register 的
没有，我应该是写。
？OK，OK，OK，你发给我看，发给我。Right, so I think I haven't enrolled you, so please email me your ID.
Okay.
Yeah, say that you are. Okay. Sure. So please send me your student.
What's your email?
My email is so my email. Yeah. Okay, sure. So can you key in your OK， 可以来 email 我的。OK，
跟你之前的是一样。
应该完全一样，但是你们学什么？
但有学 matrix 啊那些
Matrix 那些也有我们也会写的，但是我们应该会比较多的。不可能，不可能，不可能一样的，不可能一样的。我们肯定会学比较多，但是问题是赚多少多吧？对对，所以你是 first year 的，OK，first year first sem，OK，OK，不会完全一样。 Okay, for those who are here, I will take attendance first while waiting. 蔡美云. Sorry, 蔡美仪啊. 蔡美仪, sorry. You still can get me after I read the name wrong. 杜家伟. 李彦涵. 李雅涵. 李雅涵. Okay, 李雅涵. 李彦轩. 李彦轩. 翁家命. Okay. 郭书涵. 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 蒋生杰. 这首啊 ，OK。涂天天。涂天天。涂天天。王月好。王月好啊，是吗？有念错，月好。燕子轩。燕子轩。燕子轩。青烧凤。哦，青烧凤。Hamdan. Is it Hamdan? Oh, yeah, Hamdan.
Either is
Either is fine. Okay. Tê Niên Yao. Tê Niên Yao. Tê Niên Yao. Dong Hong Wei. Dong Hong Wei. Dong Hong Wei. Kok Min Jo. Okay. Lin Ke Jun. Lin Ke Jun. Lin Ke Jun. Wang Yiling. Okay. Su Xingyu. Bryson Yi. Okay. Hey Hok Sun. Hok Sun ah. Park Shin. Park Shin. Okay. I'll try my best. Gao Zhenyao. Gao Zhenyao. Gao Zhenyao. Gao Zhenyao. Jiang Fangling. Jiang Fangling. Jiang Fangling. Ran Qiu Zi. Ran Qiu Zi. Ran Qiu Zi. Huang Yunxi. Huang Yunxi. Huang Yunxi. Li Zizhen. Okay. Lin Xingyu. Lin. Huh? Not here. Okay. You are her friend. Huh? A classmate. Okay. Not here. Lin Xingyu. Miao Xingyi. Cheng Yiki. Cheng Yiki. Yike. Cheng Yiki. Nicole Dong. Okay. So we have two Xingyi here. Xua Yujie. Chao Ziyu. Chao Ziyu. Hu Shenyu. Hu Shenyu. Okay. Yuan Ruoqi. Chang Rui. Chang Rui. Okay, maybe we continue taking attendance later. If I didn't call your name at the second time, please come out to me if you haven't taken your attendance, because I'm not sure this list is updated or not. I got 85 on Sunday, but today become 90 already. So maybe I missed 5 of you. Okay, so maybe you come to me. So this class at the moment have a 90 person. 90 person. So actually it's a full quarter. Okay, so yeah. Right, so I put some phrase here. throughout this classes, right, algebra and geometry will come hands in hand. Okay, whenever we do algebra, there's some geometry behind. So for now, right, geometry for you should be like a function, sketch function. Do you know sketch function? Y equals to x. Do you know how to sketch? Can you draw for me with your hand? Why is y equals to x? Diagonal line, right? Okay, so this kind of geometry you will see, okay, whenever we try to solve function. Okay, continue. Okay, so next up. Okay, so next up we will learn system of linear equation. So this is what Handam told us just now. Okay, this is the motivation question in particular. Okay, so we try to learn it more systematically. Okay, how to solve real life problems using this theory here, or sometimes we will call these linear system in short. Okay, linear system of linear equation. Okay, so how many words here? System of linear equation. So I already told you what are the linear equation, right? So what does it mean by system? Maybe there are few of them. Okay, so this is exactly what you're going to see. So system of linear equation is a collection of one or more, okay, linear equation involving, very important, they should have the same variable. Okay, so you cannot put different variable together. Okay. So for example, what? So let's give you an example. So maybe you want to solve y equals to x, 2y is equal to 2x, and y equals to 2x plus 1. Solve it together. Okay, so the question you want to ask here is, why do you want to put it together? Because we want y and x that can satisfy three equations here. Okay, together. Okay, so this thing is what we call a solution. Okay, so definition here. A solution of a linear system. Linear system is a list of number. Okay, is a list of number x1, x2 up to xn. Okay, there are n numbers here that satisfy each equation in the system. Otherwise, there's no meaning to put them together. We want them to be true, okay, together. When the values are substituted, okay, into these xi. Okay, so in particular, like the opening question I gave right just now, the opening question, chicken and a rabbit here. So we want this number 12 and 23 to satisfy two equations here. Okay, two linear equations here. So there's a system of linear equations. Okay. Actually, I challenge you in your real life problem, see if you can figure out some system linear to solve or not. Okay, to solve your problem. Okay, to count some number. Okay, can you create some linear system? Okay, to solve. And in this course, first part of this course, we'll learn all the way, okay, to solve this kind of system of linear equation. We'll learn different way to see it. So substitution is one way, okay. But you imagine, if I have more than xy, maybe I have zw. How many substitution you're gonna do? Plenty of them. If for computer science, there are hundreds of variables you need to solve. How are you gonna do? Okay, it takes times. You can do it. It takes times. Take times means what? Take energy. Okay, take energy. You wasted your energy. So later we'll learn a way using matrix to solve. Easier way. Okay, faster way to solve. Okay. Okay, so let's say for example, can you find the solution for this example here? So what's the x and y, particular x and y that can solve this three equation together? Okay, so there's one answer given here. Answer is what? X, y equals to -1. X equals to -1 also. So do you think that there's other solution or not? Do you think there's other solution? If there's no other solution, how do you prove it? This is the only solution. Okay, to prove this is a solution is easy, right? Plug it in. Okay, is it true that -1 equals to -1? Is it true that 2 times -1 equals to 2 times -1? Is it true that -1 equals to 2 times -1 plus 1? True. But how to prove that this is the only solution? Do you have any idea? Sorry? Anyone to try? You say something, right? It's okay. Make mistake is okay. You can make mistake here, but if you make mistake in front of your boss, you know what happened? You know what happened? You get fired. Okay, maybe I'm exaggerating. In real life, right? Maybe the boss won't fire you first, but he won't take care of your viewpoint much serious. And this happened in real workspace. Okay, so if you want to make mistake here. Okay, you will learn. Okay, because now you don't have anything to lose. But in future, you're gonna lose your salary. Right? Okay, that's your life. Okay, so try and make mistake as much as possible here. Because this is school. This is the place you're gonna learn. Okay. So how to show that this is the only solution? Okay, one way to show it is like what Han Dam did just now, right? You can do substitution. Okay, you can do substitution here. So if you let's say sub 1 into to let's say the second equation here. Sub 1 into 2. What happened? You get x equals to 2x plus 1. And what? What do you get? If you play around with it. S equals to -1. Okay, so this is the only solution. But the other way is you can do graph. Okay, you can do graph. Okay, so how to graph it? So let's say we want to do a geometry way to see it. Okay, so y equals to x is like this. So why is it like this? Because you need to make sure that 1 pair with 1, 2 pair with 2. Okay, but how about y equals 2x plus 1? It should be steeper. So what's the y-intercept for y equals to 2x plus 1? Where do you intercept? 1, right? Okay. Because when you put x equals 0, you get y equals to 1. X-intercept? What's the x-intercept here? When y equals 0, x is equals to -1/2. Okay, -1/2 here. So if you join these two lines to get these 2 points together, maybe make it a bit closer here. So what do you get? You just get one intersection. Okay, so this is the -1/1 solution. Okay, a point that simultaneously sit on the two lines. So meaning what? That the two lines will intersect. So they only intersect 1 point. Okay, away from this 1 point here, they deviate. Okay. Okay, so you will frequently see this picture, geometry and algebra together. Okay. Yep. Any question? Any question? Okay, so maybe let's define it. So okay, so this also we only restrict xy to real number. So this is a real number picture here. So this is a xy plane. Okay, so xy real plane. Okay, real number plane. Okay, maybe if you do at complex number is a different story. Okay, so typically in this course, right, we'll do it in real number. That's all. Okay, we hardly go to complex number. So you just need to worry about real number. Okay, for our course setting. Okay, so if we consider all the solution together, this is what we call a solution set. Okay, so set of all possible solution called the solution set. So let's name this set here. So this set, let's say it is a script X. Okay. It's called the solution set of the linear system. Okay. So possible solution to what? To a linear system also. Okay. It's called the solution set to the linear system. So for example, the solution set for the linear equation we had just now, y equals to x, 2y equals to 2x, and then y equals to 2x plus 1 is what? It's just a set containing -1, -1 here. Okay, so this is the solution set that solves your system of linear equation. Okay, does it make sense? So there's only one point inside. Maybe there's one remark it's very important for you. Okay, if you don't know how to graph real line here. Okay, so like what I told you just now, this solution set, right, are typically subset. Yeah, typically a subset of Rn, Cn. Okay, Rm. Everyone familiar with subset, set and subset? Anyone not familiar? Not familiar, you can say, I can explain more. Typically, maybe someone from accounting. I'm not sure you learn set or subset or not. Anyone from accounting? Can I see anyone from accounting or not? You know what is set and subset? Don't know, yeah, please let me know. I will tell you immediately what is set and subset. Set and subset is very straightforward. Okay. For example, here, this is a set of students. Okay, so I collect the elements together. I collect things together. Then this is a set. Okay. Subset, sub. So subsets mean subsidiary to that set. So meaning what? I take portion of that classmate up. Okay, the student up. Okay, subset. Sub to that set. Does it make sense? Okay, subset must come with a set. Okay, so this is a idea of set and subset. So how about Rn here? Is anyone familiar with Rn here? So how do you define this Rn? Or maybe I give you a definition of Rn, then you can try and give me what is. Huh? Seems like it's a AA. So Rn. So what is Rn here? So Rn here is. Hey, hello. Oh, 送桌子来. Oh, okay, thank you, thank you. Oh, 现在第停两个人，可是下面是4。Okay, thank you. Hey, 谢谢。A lot of issue today. First day of the class. So Rn. So what's Rn here? So Rn is a set. So if it is a set, I need to tell you how the elements looks like. So how this elements looks like? Actually, they are just bracket of n numbers here. R1, R2, R2, Rn. Okay, such that these Ri are real numbers. Actually, you see this thing before. So let's put an example here. What is R2 then? Okay. R2 are like the coordinate, right? X, Y, such that X and Y are real numbers. Okay, so actually you see this kind of thing before. Just that we try to generalize it. Okay. So can you guess, what is Cn here? Anyone want to guess what is Cn here? Right, first thing about max, you need to guess. See if it is correct or not. If it is wrong, it's okay. You correct your intuition. Okay, we need to try to develop intuition for max. Okay, so if I told you already what is Rn, so what is Cn here? Sorry, bracket of complex number. Okay, let's say we call it C, in this case, C1. How many Ci here? N up to Cn, such that all these Ci's are in complex number. Okay. That's all. Okay, so one very important prototype you need to see is this prototype of real number. Sorry, real line. Okay. Although it's made out by a real number, but we want to see the geometry of it. So a prototype of a real line is y equals to mx plus c, right? Okay, y equals to mx plus c. So let's say ax plus b here. A equals to b. A and b in real number. So in general, how to plot these? How to plot this? Okay. So the general way to plot this is you need to tell me what is the x-intercept and the y-intercept. Surprisingly, the x-intercept and y-intercept is determined by this a and b here. So what's the y-intercept here? Is the b, and x-intercept is minus b over a. Can you figure out? So when it is y-intercept, x equals to 0. So if you plot 0 here, y equals to b. When it is the x-intercept, y equals to 0. So if you put 0 here, x equals to minus b over a. So basically, these two information tell you this line equation here. Okay or not? Okay. So how to get horizontal line here? How to get horizontal line? How to get horizontal line? What's the y-intercept? B equals to 0. Okay. And a, you sure? So let's try. What is this? If a equals to 1, what do you get? Y equals to x. Okay. So you really need to take a equals to 0. So there's no gradient. So another meaning of this a is the gradient of the line. So in high school, if you learn derivative before, right? So if you differentiate this line, the derivative is a. Okay, it tells you how sloppy is it. Okay. Okay, any question so far? Any question? Okay, so maybe if no question, let's try some example. Okay, let's try some example. So example here, let's give a tree system. Okay, ask you to find their solution set. So here the question is find the solution set. Okay, so you can discuss. Okay, please make some noise. Try and I give you 5 minutes. You can discuss with your friend. Find the solution set to this three linear system. Okay, I give you 5 minutes. So there are two ways I teach you now, right? So first way is substitution. Second way you can use geometry. Okay, so you can try both ways. Okay, try check your answer with your friend. I give you 5 minutes. Yeah, you can make noise. You're allowed to make noise. Okay, so first question, I think we have solved this before, right? So this answer is solution set containing 1, 1 only. Okay, so what's the geometry here? So if you follow the prototype of this drawing here, so the first line you will get is y equals to x. The other line is y equals to 2x plus 1, where the y-intercept is 1, and then the x-intercept is minus half. Okay. How about the second line? How about this line here? 2y equals to 2x. How about this line? This is the same line with y equals to x. Okay. This is the same line actually. Okay, so we have done this substitution method before. Hey, the solution should be minus 1, right? Okay, sorry. Thank you. What's the second one? So what's the solution? Sorry? All? Sorry? Many solution, good. Or what do you, you say all? R. You mean R. Okay, but how does it look like? The form is important here. What are the X and Y here? What's the x and y here? Huh? What do you mean by any? Can I put 2, 1 here or not? No, right? So it's not really any, right? But these two xy should be the same. So meaning what? It should be xx on both sides, such that x is in the whole R. Okay. So the form is important here. Okay. It's not all, not literally all. 2, 1 is not in here, for example. Let me warn you. For example, 2, 1 is not in this set here. Correct or not? Okay, 2 is not equal to. Okay. So the form is really important here. So how do you solve it? Can you tell me how you solve it? Sure. Okay, so if you divide this by 2, you get the same equation. So there's only one equation. As long as y equals to x, it is the solution. And then in this case, can you see that y equals to x or not? Y equals to x, right? Both variables are the same. Okay, so in the geometry case, what did you see? In geometry, what did you see? You just really see a line. Okay, they are the same line, actually. Okay, they are the same. So if it is in the substitution method, what did you see? 2y equals to 2x actually implies that y equals to x. Actually, they imply both ways. Okay, one way you divide by 2, the other way you multiply by 2 on both sides. Okay, so it's just one thing. How about the third one? No solution. How to write no solution here? Empty set, good, very good. So if you learn set theory, nothing, what do we call nothing as? We call it the empty set. Okay, the set is empty. Like the classroom is empty, no student. Okay, empty set. So how to see this empty set actually? How do you see it? Do you use geometry or you use algebra? Okay, if you use algebra, what do you do? Let's call the equation 1 and 2 here. So you use substitution again, right? So let's sub 1 into 2. What did you see? X equals to x plus 1. But what do you get? Equals to 0, which is a contradiction. Okay, which is a contradiction. If 1 equals 0, our world will collapse. Nothing. Okay, collapse to 0, our world. Okay, yeah. How about geometry? Can you see it through geometry or not? Anyone can see two lines that don't intersect? Okay, parallel. So how do we draw it? So we have y equals to x here, and then y equals to x plus 1. So how do you see parallelity here? You see that actually they have the same derivative. Okay, but they intersect, the y intersect at different places here. Okay, but they have the same increasing rate. Okay, if you learn derivative before. Okay. Okay, so both ways you can see there's no solution. So in the exam, right? So make sure you know all these ways. If I don't specify, then you can just use any of them. Okay, if I specify, so make sure you know which one to use. Okay, what time is it? Okay, we still have time. So there's a homework for you. Can give solution also. So there's a homework for you. So what you can see here is all the possible intersection between two lines. Okay, either you get 1 point, or you either get whole line, or you don't get any intersection at all. Okay, so now the homework is, what are the possible cases for a linear system of 3 variables? Okay, so just you can, if you notice that what we do just now are just 2 variables, x, y. Okay, let's say, how about 3 variables here? Okay, so the hint I want to give you is 3 variable system of 3 variable linear equation also have a geometry to see. So this is what we call a plane, okay, for real plane here. Okay, so what's the general equation for real plane here? It is a times x minus x naught plus b times y minus y naught plus c times z minus z. So you can see that in this case here, we not only have a, b, c in front, x, y, z, we also have this s naught, y naught, z naught. So this s naught, y naught, z naught play a role like the y-intercept, x-intercept. So how they play a role, I will draw this picture to you. Let me draw this picture to you. So how this equation will determine a plane. So you got a plane here. So how to describe a plane? Have you ever wondered how to describe a plane here? Okay. To describe a plane, right, there are really only two data I need to give you. Okay, so the first data is a point on this plane. The other data is a normal vector. Do you guys know normal vector? Anyone don't know? Don't know, you say don't know. I can explain. Don't know, okay. So what's the normal vector here? So the normal vector here means if you start from this point here, you can take any points on your plane, right? Okay, and then you can try and connect them. Okay, if you connect them, what you notice is there's only one vector. It is perpendicular with 90 degree. Again, look at this table. Look at this table here. If you fix a point here, can you find a normal vector here? What's the normal vector here? This border is the normal vector to this plane. 90 degree. See, 90 degree here. So that your border can sit on this plane. Understand? Okay, if it in Malay we say Seng. So this one is called, if you tilted a bit, okay, it won't stay, right? So it must be normal to this table here. Okay, and then every vector on this plane here should be 90 degree. See, I can put this border at every place. Still safe, very stable. Okay or not? So this is a normal vector. So who decides this normal vector? You want to guess or not? It is the vector consisting A, B, and C here. Okay, and then this particular point we pick here is x naught, y naught, and z naught. Okay, so these two pieces of information will decide this table or this plane. Okay, does that make sense? Okay, so every three variable linear equation can be transformed into this way. Any question? No? Okay, so now the question for you is, can you imagine how two planes can intersect or not? Yeah. They can intersect in a line. Okay, maybe they can intersect all together, so you get a whole plane. Or if you include the third plane, maybe you just intersect at one point. Try imagine. So go back and take a paper. Try and intersect them together. Right. So you take two papers, so you can intersect them. Okay, or you intersect them, or you can intersect in different angle. Right. So where are the points that live in three planes? Okay, try and imagine it. Okay, now I'll give a solution in your lecture now later. Okay, please think about it. So in principle, you can do it for hyperplane. Okay, hyperplane in this one 3 variable, right? Or 4 variable, 5 variable, 6 variable. But you cannot draw it anymore. We can only draw R3 at the moment. There's no R4 yet. Okay. So if you can draw R4, make sure you call me. No one in this world can draw R4 yet. Okay, so if you can draw it, please call me immediately. It's an emergency. Okay, yeah. Okay, so what's the upshot here? So the upshot here is a linear system, okay, has only really three cases. Okay, either there's no solution, okay, the solution set is empty, or there's exactly one solution. Okay, they intersect at one point. Okay, you can picture the situation, or there are infinitely many solutions. Okay, so in my class, right, make sure for everything I wrote here, you have a picture inside your mind. Okay, if you don't have that picture, you should ask me. I will tell you the picture. Okay, otherwise it's no meaning here. So when I say no solution, right, I already show you, right, there's a case there's no solution here. So you should have a picture in your mind. One solution, so maybe you have two lines intersect at one point. Okay, how about infinitely many solutions? Maybe it's just that single line. Okay, so you should have picture for all these ones. Otherwise, it's not max. It's a computation. Okay. Later, I will introduce this term again, but for first case here, if there's no solution here, we will say that the linear system is inconsistent. Okay, they are not consistent with each other, so there is no solution. Okay, at least if there's at least one solution or more solution, right, we will say that the linear system is consistent. Okay, they can solve each other. Yeah, it's consistent. Inconsistent and consistent. So this choice of word is very natural. So you need to understand it naturally. If you just learn it by heart, sorry, there's like hundreds of words you need to learn. So you can't remember one. Okay, so make sure it's make natural to you. So what is consistent means, what is inconsistent. In English first, okay, and then translate to max. And next definition is we'll say that two linear systems are equivalent. Okay, are called equivalent if they have the same solution set. Okay, so two linear systems are equivalent if they have the same solution set. So let's give some example here. Okay, it's always a good practice whenever you tell people a concept, you give people examples. Okay, so what are the examples here? For example, you have seen ones already, right? For example, x equals to y is equivalence with solving 2x equals to 2y. Correct or not? Right. Just now, some of you told me, right? Because you can divide 2 from both sides or multiply from both sides here. Okay. So can you give me another non-trivial example before we take a break? Can you give me a non-trivial example here? Maybe not so direct one, but still have the same solution set. Can you try and think about one? Two x plus y equals 0. Okay, so you mean these two are equivalent? These two are equivalent, but this is still multiplying 3 on both sides, right? So can I get something non-trivial? I mean, you can't really just do it by multiplying number both sides, but they still have the same solution set. Can you think about that example or not? You get what my question? Not just simply by multiplying or dividing or adding. I mean, multiplying first, not by multiplying. Division is a multiplication. You aware of it? You just multiply by the fraction, okay, or the reciprocal. Maybe geometry is a way to think about it, right? Geometry is a way to think about it. So let's start with this example that I gave just now. Y equals to x and y equals to 2x plus 1, right? Okay. So what's the intercept here? This is -1, -1. Okay, y equals to x. 1. Can I just simply change this 2 line here? Can I get another 2 lines to get this point -1, -1 here? In particular, I can simply pick the horizontal line and the vertical line. So what's the system of linear equation here? I can pick y equals to -1 as x equals to -1. I cannot simply get this line by just multiplication here, right? Okay, I cannot. Okay, these two are equivalent. Okay, because they have the same solution. Okay or not? Any question? So this is another advantage of thinking using geometry. You draw first. After you draw, you describe the line for me. Okay, after you draw, you describe the line for me. Okay or not? Does it make sense? Okay. So the thinking process here is not coming from algebra, it's geometry. Correct or not? Is this how you see this word? Do you see this word as a shape first? Only then you speak. Correct or not? It's not language first, right? It's shape first. Okay, geometry first. Okay, you see things first. You see the chair first before you come out with the word chair. Okay, you have the idea first. Okay, chair is the thing that I can sit on it. Okay, if I can sit on this table, maybe this table become a chair. Okay, so this is idea. Okay, we talk about idea first. Okay, then we make it precise. Okay, this is about maths. Okay, any question? Any question before we take a break? Okay, if no question, maybe we take a break until 12 o'clock. Let's take a break until 12 o'clock.
请问它这个 P 是多少
Sorry，你说什么？
波多连的 P 是多少
哦，OK，你email 我的那个，你 email 我你的 student ID，我会把你加进去。
？OK，
你已经
我没有
register 了吗？
啊，
你叫什么名？
我叫董宏伟，
洪宏伟，你的那个student ID 是什么？21啊？
对2109。
你是什么开始的
CME，
？CME，
对的。
CME 2109，董宏伟哈。OK，你 message，你 email 我你的 student ID，好，你跟我说你在这个班里。
行，谢谢。
OK，你呢？
林灿旭，
你是 SWT 什么号码
032
哪一年的
24
？24的。OK，你在母的你们。OK， 好来。
我们可以拿这个找这个吗？我们可以拿这个找这个人，我们可以拿这个找这个是能拿这两个找这个 question 吗？
喂，等一下先，不能啊，你不能够只单纯用乘号码来找到嘛，对不对？这个就是我说的 non， 这个情况就是说我可以只要它的 scalar 一变，这些东西，这些 coefficient 只要我 multiply 用一样的数字，它就会拿到另外一个，但是这个情况不一样，你一定要把 s 弄不见，对不对？但是它的重点是这个 equivalent 的意思是它们有一样的答案，就这样，
这个可以用一样的，
什么意思？
这个 x 跟 y 可以不一样号码。
可以啊，你换了过后，他们可能就不 equivalent to 这一个 linear system，因为它可能是不一样的答案。
你说你就刚刚那个
来
normal 的
呀，来，
是它的
我想想啊，我们不叫它，其实我们不叫它为 gradient，我们不叫，
不难想象诶，就是
怎么说
这
？normal 啊
这 A B C 是什么意思？
啊，就是你形容这个 vector 在 R3里面嘛，所以它需要有3个坐标才可以。
坐标
对，坐标，这个是 vector 的坐标
坐标
啊，就是来这边多少，这边多少
这边
坐标吧。这个 normal vector 我们不叫它 gradient，呀，gradient 还有其他的意思，就是说这个 plane 是多细。
我好奇就是我3个 dimension 的，因为两个 dimension m 是 gradient 嘛，
没有错
3个 dimension 是 gradient 是吧？
这个问题很好，这个问题很好，
OK，
但是嘞，
还没学到这个
这一课是不会学的，这是在考科里面会动到。
OK，
对，重点现在我们只是想要看这个 plane 的那个方向吧。对，我觉得你的问题很好，但是应该不会碰到。
attendance
OK，
ACC 讲师里面，
哪里？
这个对，
你是哪一个？郭叔？
那讲师
讲师节哦，刚才有一个同学。对，没错。不同意思 OK， 很好。你是什么系的？生意好，非常好。说这个 R 你知道吗？这个 R 我刚才有介绍嘛，对不对 ？OK，所以就是所有的数字咯，不是空白的。这个的意思其实是说活在这个层里面。等一下我会再重复一次，说这个是说里面的东西，说里面有什么东西，有1啊，有2啊，有4啊，有减，所以这些都可以是在这个位置上面的东西，这个意思。然后这里面的东西长怎样，它就是有一个括弧，然后一个号，然后这些号码是活在这个位置。For example， 这个哈，我可以写吗？For example， 如果你要问你自己，你知道这里面什么东西，你可以问你自己哦。比如说什么东西会活在这个里面，这个是活在里面第三 element， right element of。然后这里面东西，比如说有2、1，好像 maybe 有派3咯 ，maybe 有4/2咯。但是呢，你就不会看到东西像 i 跟i 加1这样，就不会看到。
这是第2题，还有谁能不能写成这样子？
我看看，可以，但是其实不可以，因为你这个意思是什么？它只有 n 个东西，其实它是无止境的。对，但是如果你要写无止境的东西，写一个就好了，反正他们就长一样。
就这样写才是。
对，因为他们长一样。对，不然你写一样对不对？对，我们这个无止境已经被这个代表，因为这里是。
有看清楚。
OK， 好，可以。
这个它是 cases 还是
cases？ 所以我有写错吗？我看这，可能我有写。在哪里 ？cases 到 cases， 这个 A 来的。
它是说
所有的可能性。比如说刚才我给你所有的可能性哦，那个两条线，然后这些呢，那 plan 有几个可能？OK， 好，好，可以，哪一个判没有？
就是这个代表是什么？
这个代表是说，如果你有一个 linear system of 3 variable 的话，怎么把这个 plane 画出来？
它不是
对，三维的，没有错，三维对，这个是三维，这是三维，这个3个维度嘛，三维这个 plane 的三维。
这个应该是一个线的。
这个画的是 plane 来的，对，然后sorry，这个画的是 axis 来的，
应该是 SY 这一。
对，没有错，对，非常好，提出这个问题。
是 就是 y，就是
哦耶。OK 啊，OK，谢谢你啊。等一下我再confirm。Okay, I will continue take the attendance while waiting. 刘浩奇 ，OK， 赵宏哲，赵宏哲是吗？赵宏 CH 宏 CE 宏 CE HONG CE Finance 2309385。哦，曹子金，no， 陈俊 Finance 说 Amber Lee，OK， Hugh Yokting，no， 哎 ，Hugh Yok no not here your friend 啊，is it your friend？OK， Ngu Yen T，OK， Faturaman is it Faturaman？OK， 林思琛，百家宁，MBT 百家宁，韦嘉怡，张岳阳，OK， 胡俊相，OK， 黄俊豪 not here， 雷乱，李坤，李逸轩 ，OK， 萧亚轩 not here， Chai B Muhammad Aziz not here， 白无称，葛文业 SWE 葛文业，郭涵宇，黄健 SWE also， 孙国东，张涵池 SWE， 钟义阳 seems like a lot of you still in China, not yet come back. Chan Tai Di, OK. 高子照 胡瑞 OK. 金世豪 OK. 李云林刘涛刘媛媛 OK. 陆央对吗？蒙瑞阳 OK. 王宏明浩瀚吴一格于泽瑞于子洲赵泽瑜 Hiba can I call you Hiba or Hiba OK. Benny Jasmine SWE. Nori Muhammad type. Sanai Raja OK. Li Shen 琼之气 Edward OK. 他只会 Mark Yi Jian Okay, so for those I haven't called your name, right? Please come to me after the class. Please come to me after the class. Okay, if I didn't call your name. And if you are not enrolled in Moodle yet, please email me. Okay, say that you are in this class and what's your student ID. Okay, please see me after the class. Okay, very good question from your class just now. There's TCM student here, right? They tell me that they don't know this notation. Very good. Please let me know. I can teach you on the spot one. Okay. So what are these notation here? What is this? Do you think what this looks like? Looks like what? This form. Can you imagine what this looks like. E, right? Okay, so what's E here? Element. Okay, so element of a set. Okay, so this is an element of a set, real number. So what are real number here? Maybe 1 or 2 or pi, e, half. Okay, so these are the element in here. And what else I just now say? Okay, another thing is, you see, I put a lot of this arrow thing. What do you think these are? These are the axes. Okay, so they should be labeled properly actually. Okay, so how many axes? 2 axes, xy, 3 axes, x, y, z. Okay, 4 axes there. I don't know how to draw. Okay, don't know. Okay, we can only draw 1, 2, and 3. Okay, x, y, and x, y, z. That's all. Okay, so that's why there's no homework for you for 4 variables one. Okay, so up to 3 variables. Okay. Okay, so very good. Please continuously give me feedback. So I need to learn about your group. Okay, so that I know what to introduce to you. Okay. Let's continue. Okay. So let's continue. So what did you observe throughout our calculation here? So if I gave you a linear system, right? If I give you a linear system, actually, the solution set remain unchanged under 3 elementary equation operation. Okay, let's discuss about these 3 types. With the 3 elementary equation operation. Okay, so what are these 3? So first one you know very well, right? Scaling. Right, just now we did scaling here. So what is scaling here? We can scale all the entries in an equation by a non-zero constant. Not here, non-zero constant. If you multiply by 0, what happened? 0 equals to 0. Okay, so you change the original equation. So I'll give an example here. So just now we already see, right? Y equals to x is equivalent to 2y equals to 2x. But there's one more easier elementary equation. Okay, elementary equation operation that also doesn't change solution set also. Can you imagine or not? It is the interchanging, okay, interchanging 2 equations. Okay, so what do I mean by this? So for example, you need to solve y equals to x and y equals to 2x plus 1. But this is equivalent to solving y equals to 2x plus 1 first and then solve y to the x. It's the same. No, not. Because as long as you satisfy these 2 equations, you should get the same solution. Yeah. Okay, so actually this is even easier. So interchange 2 equations. So the last one is not as trivial. Okay, so this is called replacing. So what sort of replacing you can do? You can replace one equation by the sum of itself and multiple of another equation. Okay, so let me give you an example here first. So for example, again is the same example here, y equals to x and y equals to 2x plus 1. Okay, so for example, I can keep y equals to x here. But for the second one, what can I do? I can add the first equation to the second equation here. So let's call this first, let's call this second. And then if I add these 2 together, what do I get? I get 2y plus 3x plus 1. So the claim is they have the same solution. Okay, do you agree or not? Do you agree? Okay, maybe to convince you, we should solve it first, right? Let's solve it. Okay, either you want to use geometry way, algebra way, both can. Try and solve it. So give me the solution set for these two equations here. So first of them, I mean, we already solved it, right? So this x1 is, this x1, when we solve it few times, right? -1 and -1. How about the second one? Can you solve it? Same. Okay, how do you how do you see them as the same? So this is 1, let's call this 3. So sub, again, if you want to use algebra way, sure, use algebra way. Sub 1 into 3. Okay, what do you get? 2x equals to 3x plus 1. X equals to -1. Can follow? Can follow? Okay. And then x equals to 1, sub it back again to equation 1. You will get y equals to -1 also. Okay. So if you plot the line, right? Okay, if you plot the line, how to plot the line? So I ask you to get this line into a specific form, right? Y equals to mx plus c. So can you do it? Can you turn this line into a mx plus c form? From 3, what do you get? Y equals to 3 over 2 x plus half. Okay, so if you plot this line out, what do you get? So 1 is y equals to x. So here is x, here is y. And then the other one, you have a y-intercept as at half. And then the other intercept, where is it? What's the formula? If you calculate it, you get minus b over a. Okay, so if you do it in our case, what do you see? Minus b over a. So minus half over 3 over 2. What is this number here? What's this number? Minus? Huh? Sorry? Minus 1 over 3. Good. Okay, so put it closer. Minus 1 over 3. Okay, so you should verify that the intersection point here is still -1, -1. Okay, not straight. Wait, -3 should be closer, right? Minus half, 1/3. Okay, so you should verify that this point is still -1. Okay. Okay. Okay, so I mean, if you think about it, right? Okay. If you think about it, if your solution gonna solve equation 1 and solve equation 2, obviously they will solve them together. Okay or not? Okay, so if you add them out together, we'll get the same solution. Another one is that there's two part here. There's two part here. So sum of itself with a multiple of the other one. So multiple here, you can scale it. Why you can scale it? Because we already know that scaling a equation, you won't change the solution set. Does it make sense? Okay. Any question? Question. Okay. So in particular, for example, let me give you another equivalent linear equation here. So, well, what you can do is you can consider the third one. So let's minimize these sides. Okay, maybe you can get the third linear equation here. So for example, what can you get? You can try and, so I left this as a homework. Try go back and verify they have the same solution. So maybe you have y equals to x. What you can do is 1 plus 2 times 2. Okay, get the fourth equation here. So what do you get here? So you should get 3y equals to 5x plus 2. Okay, see if you can verify they have the same solution set. Okay or not? Okay. I mean, maybe we can do it more directly here for you, like y equals to x plus 2 times y equals to 4x. Okay, this is how I get this 3y equals to 5x plus 2. Is it clear? Clearer? Okay. So I'll try and verify that they are equivalent. Yeah. Yeah.
I have 3 equations in a set. Yeah. Do I just add 2 or do I add all 3 together? Together.
Let me think. You can do anything. Can do anything.
You can add all.
Sure. Yeah. Sure. Yeah. You can. Yeah. So the point is why you can do that. You think about it. Why can you do it? What can you think about why you can do this? Why can you? I simply add 2 equations still works. Can you think about it? Why is it true? So this is a process of proving why it works. So can you try and think why or not? Let's say you have a solution that can satisfy 2 equations, or not? And then you just add them together. I mean, you just add these 2 equations together. The solution should still satisfy. I mean, well, okay. So let me show you. So for example, this. How this? Let's say, okay. Let's make these smaller even. Let me show you. Resize. I'm kind of like trying to prove to you, but we don't write it as a professional words. So how we get this 2y equals to 3x plus 1 from? Do you know? You have y plus y equals to x plus 2x plus 1. So you can see that you can split this two side into 2 parts, right? But imagine if you have a solution that can solve this part. If you have a solution also solve this part, then you add them together, you still solve it. Does it make sense or not? Okay, maybe x and y is a bit confusing for you. Let me try another thing. Let's say I know that 2 equals to 2. I know that 4 equals to 4. Obviously, 2 plus 4 equals to 2 plus 4. This is the point. Okay or not? Whenever we say equal, although you say that x and y look different, but this is the power of equal. Equal meaning they are equal. They are the same thing. Okay or not? Does it make sense? So this equal signs, you need to be very careful, okay, about what we put beside these 2 equal signs. Whenever we say 2 things are equal here, they're really equal. Correct or not? We must make sure the x and y we put inside here, they are equal. Okay. So for example, to solve this, right? What's the x and y that solve this second equation here? I give one example. It's a line, but just give one example. -1 and -1. Okay. So why solve it? Because if you sub it in, what do you get? What do you get if you sub it in? What do you get? If you sub -1 inside here, what do you get? Do it step by step. Okay. -1 equals to 2 times -1 plus 1. In the end, you get. Okay, before that, okay, you will get -1 equals to -1. Done, no? No, no, because -1 equals to -1. Okay, to get 0 equals 0, what do you do? +1. Plus 1 on both sides. Okay, but it's okay. -1, I already know is equal to -1. That's all. Okay or not? Okay. Okay. So why adding 2 equations will still have the same solution set, actually rooting from this kind of argument here. Okay, if I know that 2 equals to 2, 4 equals to 4, I just add 2 numbers together. It's still satisfied. Okay. Okay, so let's do example now. Okay, let's do example. So I'm gonna teach you the third method to solve a system of linear equation here. So let's say we're gonna solve this system of linear equation. Okay, I give you chance. Maybe I give you a shorter times now. I give you 2 minutes to solve this. Okay, I don't want to show you how to solve it first. I want you to solve it yourself first. 2 minutes to solve this. Okay, I give you shorter time. 2 minutes, solve this x1 and x2. And then I'll discuss my way. You can use whatever way I teach you just now. Okay, later we'll check solution together. I give you 2 minutes. Huh? You can discuss with your friend. Okay, so let's see what I get. You can compare with yours. If there's some discrepancy and then you cannot accept. So the first rule in the class, right? You should think that you are correct first. Okay, you should think that you are correct until I correct you. And then you think that, is this lecturer saying the right thing or not? And then you try and argue with me. And then I will tell you what's wrong. And then this is how you learn. Okay, it's not like some of the students I will say, hey, teacher, help me to check this. Tell me right or wrong. Just tell me right or wrong. Okay, this is not a right way to learn things. You should be more specific, asking maybe, teacher, this step to this step, you think correct or not? Or is this true? Okay, or this implication is true or not? Only in this way you know why you are calculating in this way. You are not just copying step, because the question will change, rapidly change. Okay, if the question type change, then you don't know what answer to put. But the question type won't change the principle of that question. Okay, the idea of the question, the thing that I want to test won't change one. Okay, I can change all type of question, but the solution is the one that you have seen before. Okay, you understand? Okay, so make sure you learn it in a proper way. So first thing, what do I do? Okay, so let's see what I do. So I'm gonna do this. I'll take equation 2, again, minus equation 1 times 3. Okay, 3 times equation 1. So what do I get here? So let's spell out my step. So 3x1 minus 7x2 equal to 5 plus negative 3. So negative 3 times equation 1, I get x minus x1. 3 times minus 3 times x1 plus 15 x2 equals to minus 3. So in this case here, I'll get 8x2 equals to 2. Okay, so in the end, if I scale it properly, I'll get x2 equals to 1/4. Let's call it equation 3. Next step, I'll get 1 plus 5 times 3, equation 3, which is I'll get x1 minus 5x2 equals to 1 plus 5x2, which is equals to 5/4. Okay, And in this way here, I will get x1 equals to number 4. Okay. Actually, secretly, this is also a substitution. Actually, this is also a substitution. Okay, just I do it equation by equation. Okay, actually, this is a substitution here. Do you all get these two answers? Okay, good. So in exam, right? Does no teacher tell you the answer? Can you check yourself or not? How to check? Good. Okay, so you can do a sanity check here. So let's call it a sanity check. Sanity check here. So after you get these x1, x2, right? Try and substitute back. So if you substitute back, do you get 9/4 minus 5 times 1/4 equals to 1 or not? Okay, and do you get 3 times 9/4 minus 7 times 1/4 equals to 5 or not? Okay, so check it. Okay, do the sanity check. Yeah. Where? So okay, thank you. So I swap them, huh? Okay, thank you. Yeah. So if I swap it, obviously you won't get 1, obviously you will get 5 for the other one. So try and check, sanity check. I think in this course, right, I won't ask you to do very difficult calculation. Okay. Maybe even if you can calculate well, you don't need calculator also. Okay. So, but these are the things that you need to know how to check. Okay. Yeah. Yeah. Ali, which one? What's wrong? Wait, what? Hey, so what's wrong? Sorry. So what's wrong just now? I didn't listen carefully. What? Huh? Did I swap? I didn't swap, right? Did I swap? Well, I mean, okay. So let's do the check. Let's do the check. So 9/4 minus 5/4 is what? 4/4. So it's 1. And then the other one, we get 27/4 minus 7/4. We get 20/4, which is 5. Okay, yeah. Any question? Got question? Okay, so now I'm gonna teach you, Jem. I'm gonna teach you another way, third way to do this. What did you realize here? Actually, x1, x2 not important. What's changing is the coefficient. Okay, let me show you. So let me show you. Actually, x1, x2 is not important, no? So let me show you. So what's important is this coefficient here. So let's pick out the coefficient. 1 minus 5, 3 minus 7. Okay. And then on the B side, we have 1 and 5. So we try and use one line to split the AI and B. Okay. So this is what we call the augmented matrix here. Later I'll define it properly, but for now I'll tell you the terminology. What happened in this line here? What do? I really take row 2 minus 3 row 1. Let's see if they get the same effect or not. So I keep row 1. And then I do something on row 2. Okay, I do something on row 2. So if I take the row 2 minus 3 row 1, what do I get? 0, 8, and 2. Okay, which I get this. Okay, so actually this step here is changing row 2. Okay, how about next step? Can I use the same logic here? What do I do next? Actually, I scale this, the new row 2. Okay, I scale it by what? 1/8. Okay, I scale it by 1/8. So if I divide by 8, what do I get for row 2? I get 0, 1, 1/4. So I get this. There's no S1 here, right? So that's why the coefficient 0 here. Okay, and then next thing, can you translate this for me? R1 plus 5 times. So now this third equation still in R2, right? So this is R2 here. So we keep R2, we change R1. What do you get? 1, 0, 9 over 4, 0, 1, 1 over 4. How to translate to these two things? These are the coefficient for xi, and then this is the b. So for the first one, we get what? x1 plus 0 equals to 9 over 4. The second line, 0 plus x2 equals to 1 over 4. This is exactly x2 equal to 1 over 4 and x1 equals to 9 over 4. Okay, actually, you don't need to spend so much time writing down this x1, x2 anymore. You just solve it using matrix. Have you all seen matrix before? Okay, later we will introduce matrix again. Okay, so this is the first place you see matrix now. Okay, so instead of doing algebra, geometry, look at the matrix. Okay, do the row operation. Okay, do the row operation. Any question? This is very important example actually. You must remember this example. Tomorrow, after you wake up, look at it again. Because this is really the example you need to appreciate to go to the next part. Okay, just as simple as this only. Okay, how to go from this row substitution to row operation on the matrix. Okay or not? Okay. Yeah. Okay, so let's define this augmented matrix, and then I'll tell you some technique to do. So the homework here is to appreciate it. Appreciate it, okay? Every day. Okay. So let's define this augmented matrix now. So in general, okay, so given a linear system, let's say you have n variables here. Okay, let's say you have n variables. So these n variables come with a different coefficient. So you might be wondering, hey, why you need two subs, two indexes? Why do I need two indexes? Sorry? Good, very good. So one will control the number of variables, the other will control how many equations. Okay, so let's use the first index to control how many equations here. So let's say we have m equation here. Okay, so we have m equation with n variable. Okay, so in your mind, you should think that the matrix grow in two ways, okay, horizontally and vertically. Okay, so there are two sort of matrix we can get from here. So one, we can form its coefficient matrix. Second, we can form it, sorry, I spelled wrong, coefficients matrix. The second one is called the augmented matrix. Oh, this is what I mentioned to you just now. So when I say coefficient matrix, right, it means it just consists of the coefficient. So what are the coefficient for the variables? It's just these AI, Aij. Okay, these Aij. Are you guys comfortable with saying Aij or not? I and J can change. Okay, I cannot spell everything for you, right? A11, A12, A13. So use I and J to change. Okay. And so what's the augmented matrix here? We try to include all the B's. Okay, we try to include all the B's together. So a common practice to do this augmented matrix is you draw a line, okay, between these coefficient matrix and the B vector. Okay. Maybe in the textbook, you won't see this line here, but you should be aware of what kind of a matrix it says. Okay, in the solution manual, maybe they don't put this line. This also confused me when I first learned linear algebra. So you try to check whether the solution is trying to talk about augmented matrix or coefficient matrix. Okay, but in the quiz exam, make sure you draw this line. Okay, make sure you draw this line for augmented matrix. Okay or not? Any question about notation? Okay, so I want to be careful with your tutorial exam. I mean your textbook solution. Okay, so in this case here, let's copy this. So now we have a bridge now. Okay, so we have a bridge from a system of linear equation to this matrix here. Okay, so we have bridge now. Do you know what's a bridge? Bridge. So a bridge connecting two places. Okay, quite similarly different, right? Quite different, no? Quite different. In particular, did you see any equal sign here? No, right? So we replace the equal sign by the line. Okay, this line is the equal sign here in particular. How about the variables? How do we remember the variables? This is the position of your coefficient. So in particular, the first column is for x1, second column for x2, and then for Sn. So, okay, for B, it's a coefficient of 1. Okay or not? Does it make sense? Okay, in future, we will generalize this idea further, okay, which we call basis in future. For now, you should remember these are the coefficients for this variable. Okay, we no longer need to write S1, S2 already. Okay, what's important is the coefficient. And then there's a matrix of coefficient. So since these three operations doesn't change the solution set of your linear system, you can also translate it into a language of matrix. So this equation will become what? Become row. Row of the elementary, row of the augmented matrix here. Okay, so all these equation here, you can change it to elementary row operation. Okay, so for example, in this case here, what's the augmented matrix for the first case here? Can you tell me? One, depend on which one you want to write. Okay, you can do 1, -1, and 0. The other one, 1, -2, 1. So in this case, do you notice that your first variable is not x instead of y? So you need to be careful. Okay, don't in the exam you put y, x here, then in the end the solution swap. You get what I mean? So you need to be aware what your y and x is. Maybe a very good exercise is you can put here or you label. Okay, your first variable is what? For example, I give you an example. There's one confusion you can make here. So in this case here, let me give you the example we had just now. So let's say we have this solution here. Here, we by convention, we said that first column is x1, second column is x2. But let's say like what you did just now, you swap it. You swap it. Okay, if you swap it, what happened? So let's say in the case you did just now, still the same matrix. Okay. Okay. But you swap it. Here is x2, here is x1. But you forgot in the exam. You think that x1 comes first. So you write x1 equals to number 4, x2 equals to number 4, then wrong. Okay, so make sure if you swap it, you have to read your matrix properly. Okay, does it make sense? So a very good exercise practice to put here is maybe you label your column to remind yourself. Okay, to remind yourself. Okay, good. Right. So how about the other one? So maybe the other one, the augmented matrix should be just replacing, interchanging row, right? So you should get 1 minus 2, 1, and 1 minus 1, 0. Something like that. Okay. Yeah. Try and do for the other two cases. Yeah, try and work out for yourself. Any question? No? Okay. So just now, what did we did? After we introduce system of linear equation, right? We tell you when are the two system of linear equation equivalents when they have the same solution set here. So here is the same also. Okay, so definition here. So when are the two matrices are called row equivalent? Okay. So when are the two matrices are row equivalent? If there is a sequence. Okay. Sorry. And if there is a sequence of elementary row operation. Sometimes we will take abbreviation of these elementary row operation as ERO. Okay. Sometimes to save times. That transform one matrix into the other. Okay, so for example, okay, let me give you an example. So we have a new concept here. So I'll give you an example. For example, these two augmented matrix is the same. It's row equivalent. Same in the way of row equivalent. Why? Why? What's the ERO that you can take here? Do you remember what kind of ERO you can take? There are three types: interchange, scale, and replacing. Okay, replacing means what? Take the sum of multiple of the other. Okay. So what can you do here? This three step you must memorize. Scaling, interchange, and replace. Okay, so what step you can do here? If I say that they are row equivalent. Scaling. Scale by what? 2. Good. Okay. So this is exactly the same idea, right? Y equals to x, 2y equals to x, are equivalent. Okay, but why is it better here? No y and x anymore. Okay, no more y and x. We save time. Okay, we save time. Okay. Okay. All right. Cool. So there's a theorem here which we're not going to prove, but you need to remember the logic flaw here. So if, let's say we have a system of linear equation, okay, and then we output this augmented matrix, right? Okay, so how do we calculate the solution here? What do we do in this example here? We do elementary row operation. After we do, we claim that, hey, this solution we get from this ERO after doing ERO is the same solution you get from algebra substitution. So we need a theorem to tell us this is always true. Only then we can do it in this way. Otherwise, it doesn't work, right? Okay, if for some cases doesn't work, then don't work. Then we throw this method. So this theorem is very important, such that we cannot throw this method away. So if in the case that the augmented matrix of two linear system are row equivalent. Row equivalent means what? There is a sequence of ERO. So you can only take that three types only: scaling, interchange, and replace. Only these three types. Then the two system will have the same solution set. Okay, the linear system that you start with will have the same solution set. So this theorem tells you that you can safely use the matrix method to calculate your solution. Okay, so this is very important point to appreciate here. Okay, does it make sense? Okay, so to appreciate this theorem is you can safely use the matrix. So you have a linear system, take out the augmented matrix, do the ERO, okay, get the solution. This is a solution that you need. Is it? If and then, can you Understand what is if and then? If P, then Q. So meaning P happens, Q must happen. Yes. If P happens, Q cannot happen, then this is a false theorem. Okay. Does it make sense? Okay. If P true, Q must true. Okay. So this part is a P, this part is a Q. For P true, if P, then Q. So the logic is P true, Q can be true. Okay. Does it make sense? Okay. Can we go backward or not? If Q true, P true or not? Not true. Why? Sorry? Sure, can be coincident, but if you say something is not true, right, you need to show to people. So how do you show to people? You need to give a counter example. Okay, so I put a remark here. Maybe I can provide you, but you can think about it. So the converse is not true. So we call it converse if we go backward. Okay, the converse. If Q, then P is not true. So the question is, can you give a counter example or not? If you can, then you prove it. Yeah. Can you give a counter example? So counter example means what? Identify the things you need to do first. Find two systems that have the same solution set, but you cannot use ERO to move one to the other. Okay, maybe think about it. Let's say in a real mathematics case, if you think that you cannot find this counter example, what should you do? In a real case, you scratch your head, try all the example already, no counter example. What should you do? The other way, you should try and prove it. Prove that it should be true. Okay, yeah. So my claim here is try and find a counter example. Okay, try and find it. Okay, continue. So since this theorem works, so we're gonna use this theorem to solve a bunch of questions. Yeah, let's try some question. So let's try some question here. So again, I want to remind you. So when is a linear system consistent? Anyone still remember? Where is your linear system has a solution? Okay. Not necessarily many. At least one is enough. Okay, as long as you have one. Okay, not as necessarily many. When is it inconsistent? Only one case. Okay, so it has no solution, meaning the solution set is a empty set. Okay, nothing inside. Okay, so before we finish up today's class, so let's try and determine whether this system is consistent or not. Try use the matrix way to solve it, and then we will compare this question here, the solution. So what's this system here? Let me copy down for you. So it is x1 plus x2 plus 2x3 equals to 9. 2x1 plus 4x2 minus 3x3 equals to 1. 3x1 plus 6x2 minus 5x3 equals to 3. Okay. So by looking at this question, right, you should think about something already. You should expect something. Okay. Doing maths, there's one myth, some of the students or some of the people see a question, quickly compute. I don't know what things to compute one. Okay. If you read this question, right, there's something to expect here. What do you expect? This question asks about what? Consistency of this linear system. So to prove that this question is consistent, what do you expect? That's a solution. If you want to show that this system is inconsistent, you need to show that there's no solution. Okay, so you need to expect these two situations to come out. Okay, so try and use the augmented matrix method to solve it. Maybe I give you a hint. So what's the augmented matrix here? So this is equivalent to ERO on 112924. Okay. Do you have an end goal matrix looks like or not? You know what's the end goal here? You want to find x1 equals to y, x2 equals to y, x3 equals to y, right? So you should have 1, 1, 1 on the diagonal, and then 0 on the off diagonal. See if you can make this matrix into this form or not. Go and try. Okay, I want you to try. Actually, mathematics is about trying. So if you make mistake, you know what's wrong. Okay. Yeah. But there's a time limit here. We'll start discussing at 12:50. Okay, maybe we go a bit further. 5-minute delay because we have a lot of accident today. Okay, it's okay that if you haven't finished yet. So let me show you. I think I'm not sure there's a last step or not, but I have 1, 2, 3, 4, 5, 6, 7, maybe 7 steps like that. Okay, so let's see what I'm gonna do. See if it's the same as what you're doing, what you have been doing. So the first step I'm gonna do is I do row 2 minus 2 row 1. Okay, I'm changing row 2 here. So I get 1, 1, 2, 9, and then 0, 2 minus 7 minus 17, 3, 6 minus 5, 0. Okay, so the point here is I want to try and make there's only single 1 on the first column here. Okay, and then the second step I'm gonna change, obviously I'm gonna change the first item in the third row to be 0 also. Okay, so that I get 1, 0, 0 all the way. Then I get, what's the third row here? So I get 3 minus 11 minus 27. Oh, next step. Yeah, maybe I keep the goal here. So this is our goal matrix. Put Z1, Z2, Z3 here. See what's the end goal here. Okay, so what's the third step? I'm going to make the second entry in the second column here non-zero. Okay, so I'm going to make 1 0 and 3 0 here. So the first thing I'm going to do is I take 2 row 1 minus row 2. So I change my row 1. Okay, if you can, you follow my calculation first. And then you can finish your own calculation at home. Okay, see if we get the same answer or not. There's no single answer works, huh? But the same principle works. So let's say I'm going to change row 3 now, such that I get 0 2 0. And then the rest, what do I get? -1 and -3. Okay, so I almost get this diagonal form already. What else I need to get rid? 11 and -7. Okay, so let's continue. So let's continue. I'll get row 1 plus 11, row 3. You see, the row that I reference always is the row that I want to keep. Okay, the row that I want to keep. So we get 2 0 0, and then 2 0 2 -7 -17, and 0 0 -1 -3. Okay, and then the last one to do is row 2 -7, row 3. Okay, such that I get 2 0 0 0 2 0 0 0 2 -1. Okay, I almost get the goal already. So what else I need to do? I almost get the goal already. What else I need to do? How to get 1 1 1 here? You scale them. Okay, you scale. Okay, so you can scale them at once. Okay, you can take half of row 1, half of row 2, and minus R3 here. You get 1 0 0 0 1 0 0 0 1. And you get 1, 2, and 3. So this solution set says what? X1 equals to 1, X2 equals to 2, S3 equals to 3. So there is a solution, meaning the system is consistent. Okay, so can you do the sanity check? So what should you do for sanity check? Put this 1, 2, 3 back to your 3 equation. Okay, check that is correct or not. Check that your calculation is correct or not. Okay, so please do sanity check. Okay, so before we go back, before I release you, before that, so there are 2 technical points. So check yourself. So there are a few technical points I want to remind you so that you don't confuse yourself with your step here. So first of all, we will write A times R1 plus B Rj to replace, okay, the row Ri. Or we can do row changing, right? Interchange, okay? So typically we put the one that you want to change at the first place to remind yourself. If you swap here, swap there, I don't know which row you want to check. Correct or not? So we make a convention. If you're going to change row 1, put it at the first Ri. Okay? So that you can also check, right? Don't swap here, swap there. Okay? So for example, let me show you for example. In this case here, obviously, I can write minus 2R1 plus R2, right? But this is not clear you want to change R1 or R2. Okay, if you're going to change R2, then you don't write the second form. Does it make sense? Does it make sense or not? Because these two result the same row. Yeah, so which row you want to replace? Okay, so if you're going to change R2 here, so let's see, you see, the changing is here. So put R2 first. Okay, if R2 is changed, put R2 first. If R1 is changed, then you put R1 first. Okay, does it make sense? Any question? Please ask, please ask. Okay. Second, in principle, you can only do row operation once. Okay, but you can see that why I can scale 3 of them at once. So the warning here is you can do multiple ERO at a time, but make sure that you only replace one row once. Okay, so meaning you don't like combine these vertically. Okay, don't do it vertically. You see, why I can do it this multiple ERO once? Because I only change R1 once, R2 once, R3 once. You cannot change R2 and then change R2 again. For example, what? Let's see. Can I? For example, maybe you combine these 2 steps together. It's a different thing already. Okay, so we try not to confuse ourselves. Split it. So if you are a person that very discreet, very scared, you can even split these 3 steps also. It's okay. Okay. But make sure when you combine, you know what you are doing. The problem is you cannot do subsequent composition together because these were gonna confuse you. Okay, you will do mistake one. Okay, so a general principle is you can do as long as you just replace a row once. Once can. Okay. Okay. Any question? So there's another question in your notes. You can do it left as a homework. We can discuss at the start of next class. Okay. Any question? Okay, if no question, we'll see you on Wednesday. So if I haven't taken your name or you are not in the Moodle yet, please find me if you haven't find me yet.